Yeah. Folks, do you remember about what we discussed in the last class regarding multi-threading? Do you remember what we discussed in the last class regarding multi-threading, guys? Anybody have any idea on multi-threading? Have you remembered like what we discussed in the last class regarding multi-threading?
Thread synchronization.
Synchronization, sir.
Very good. So I have just given an example also, which is related to thread synchronization, where we discussed about synchronization, right? There is a keyword
Yes,
called a synchronized keyword. Cool. Okay. Now I just want to continue from there. So when two threads are at a time trying to make some changes to the same object, then one thread made changes will affect on the other thread also. So what is the concept now? We want to prevent that. Suppose if two threads wants to at a time work on the same object, then we want to allow only one thread at a time to work on a particular resource. Resource, I mean particular object. That's where we got concept called as synchronization. Okay. So synchronize is a keyword that we can use with method. And we can also create a synchronized block. So today I'm going to talk about a concept called a synchronized block. We have synchronized method and synchronized block. So I'm going to talk about synchronized block now. Okay. Actually, synchronization, thread synchronization can be applied on methods and blocks. We have synchronized method is there. Similarly, synchronized block is there. So let's understand about which is better to use or when to use what. Okay, that's all we want to understand now. Okay, see, for example, assume that I'm making a method as a synchronized method. How can I make method as synchronized? There is a keyword called synchronize that we read before the method. That's how synchronize. That's how we can create what synchronized methods. Okay. Let's say, for example, I'm creating one synchronized method. Public, let's say synchronized. It's a method. Let's say method is method one, and there is some, return type is void. Okay, synchronize the keyword. Void is a return type, method one. Okay, and here I can start writing some statements. Let's say, for example, I have statement one. Let's say stmt1. This method has multiple statements. Let's say stmt2, 3, 4, 5. stmt3, stmt4, and stmt5. These are the different statements in my method. 5 statements are there. So as you know that, okay, for example, if a thread one has got the chance to invoke method one. Okay, since it is a synchronized method, then thread one got the lock of this object. This method is there in a class. Okay, to invoke the method, a thread will use object of the class to invoke this method. So now thread one got the lock on that object. Lock means a monitor. We can say simply lock. A lock on the object. Okay, thread one got the lock on the object. So now thread one is executing this method. What about thread two? Thread two has to wait until thread one has completed this method. Once this method execution is completed, automatically thread releases the lock. So a thread acquires lock on the object to invoke the synchronized method. So if a thread wants to invoke this method, first thread will acquire lock on that object. Suppose thread one acquired lock. Thread two also actually want to invoke, but first thread one got the lock. I mean, thread one has acquired lock on that object. Then thread two will wait. So how much time the thread two has to wait? until the lock is released by the thread. When does the lock get released? Automatically, once the synchronized method execution is completed, lock gets released. The object lock will be released. Okay. Now there are 5 statements in the method. 1, 2, 3, 4, 5. Tell me how many statements, how much time the thread 2 has to wait now? So thread 1 is invoking this method. Let's say, for example, thread 1 is invoking this method. Thread 1. What about thread 2? Thread 2 is waiting. Thread 2 is waiting. T2 is waiting because a T1 got lock on this object and T1 is invoking the method. And when T1 enters and starts executing the method, statement 1 executes, statement 2 executes, 3, 4, 5. Until all these statements are executed, thread 2 is waiting. Okay. After all the statements are executed, then the lock, the thread releases the lock on the object so that the next thread will get the chance to acquire the lock on the object, because at a time only one thread can acquire the lock on an object. And now thread 2 got the lock and thread 2 will enter. It will start executing the method. Actually, out of 5 statements, there are only 3 statements which comes under critical section. There are only 3 statements comes under critical section. I mean, only 3 statements are critical. But remaining 2 statements, let's say 4 and 5, they are not critical. They are normal statements only. I mean, if 2 threads execute statement 4, 5, there is no issue. But there may be a chance, okay, or there is a critical section called as 1 to 3 statements. Only 3 statements of the method are critical. 4 and 5 are normal. Which means, for example, if thread 1 enters, because you made this method as synchronized method, so thread 2 has to wait. For example, thread 1 has got lock on the has acquired the lock on the object. Now thread 1 called M1 method 1. So how much time thread 2 has to wait? Until all the 5 statements are executed. Thread 2 has to wait for until all the 5 statements are executed. But actually, last 2 statements are not a critical section. They are not critical statements. But still, thread 2 is waiting until all the 5 statements are executed, which means there is a more waiting time for thread 2. So when only some statements in a method are critical and only one thread you want to only one thread can execute those statements at a time, then don't make directly the method as a synchronized method. You can write synchronized block. So when a thread is executing a synchronized method, other thread has to wait until all the statements of the method are executed. After executing all the statements only, a thread will release the lock, and so that other thread will get a chance to enter into that method. Okay. So waiting time will be more. If all the statements are critical, for example, let's say all the statements 1, 2, 3, 4, 5, what we say, if all the statements are critical statements, correct? If in case all the statements are critical, then you can do one thing. If all the statements are critical, then you can make the complete method as what? Synchronized method. Okay. If all the statements are critical, you can make the method as synchronized method. But if only some statements are critical, don't make complete method as synchronized, so that waiting time will be increased. That's why we have one more concept called a synchronized block. So what can I do here? I can write something like this. Okay. I write the points now. Okay. If you make a method as a synchronized, then a thread has to wait until all the statements of that method are executed by the other thread. Okay, until all the statements are executed by the other thread. You have to wait now. Okay. So here what is happening? Actually, if only some statements of a method are critical, then don't make complete method as synchronized. It will make waiting time increased for other threads. Right? That's where we got a concept called as synchronized block. Okay. So if only some statements are critical in a method and only one thread should execute them at a time, then don't make the entire method as synchronized. You can just keep only such statements, only those statements you can keep. Okay, only those statements you can keep in the synchronized block. So if some statements are critical, section, if some statements are critical section in a method, then don't make entire method as synchronized. Then what we can do? You can keep those statements in a synchronized block. That's what concept. Okay, now if some statements are critical section in a method, then don't make the entire method as synchronized. You can keep those statements in a synchronized block, so that what waiting time will be less. For example, in my method, only first 3 statements are critical section. Then I can write like this now. See, public void method 1. No synchronized method is. I'm not writing the synchronized keyword for the method. I'm writing simply method 1, just like a normal method. Inside the method, I will write what? Synchronized block. I'll say what? Synchronized of. Whenever you write synchronized block, you should pass parameter. Parameter is an object. When you are calling synchronized block, you should pass a parameter. The parameter of a synchronized block is an object on which a thread is going to acquire the lock. Mostly we read this. Okay, this means the current object of the class. So we read synchronized of this. And here we read, for example, statement 1, statement 2, statement 3. Okay. Now, what about statement 4 and 5 outside? Statement 4, statement 5 are not critical statements. They are just only simple statements. Now, what's the advantage of writing this block now? Whenever, for example, if thread 1 acquired the lock. Okay, thread 1 entered into synchronized block for execution. Thread 2 is waiting. How much time? If a thread 1 completes the block, and when thread 1 enters out of this block to the next statement, then thread 2 will enter. Now the waiting time of thread 2 is less when compared with the previous example. That's how synchronized blocks comes into the picture. That's how we need to apply the concept called as synchronization. So there are 2 things. You can make the entire method as a synchronized, or you can just keep some statements in synchronized block. It all depends on whether all the statements in a method are critical and to be executed by only one thread at a time, or only some statements in the method are critical and to be executed at a time. Based on that, you decide whether to write synchronized block or synchronized method. Am I clear with you guys? Did you understood about the difference between both of them?
Yes, sir.
Okay. You understood about synchronized block and synchronized method? Correct. What I'm saying now, so comparatively, which one can provide better performance? Synchronized block or synchronized method? Comparatively, synchronized block is better or synchronized method is better to improve the performance?
Block.
Yeah. Okay. The answer is what? The answer is what? Synchronized block is better. Why? Because it reduces the waiting time for the other threads. That's why synchronized blocks are better than synchronized methods. Okay, because synchronized blocks will reduce waiting time. But of course, if you want to, if all the statements in a method are critical and only one thread can execute them at a time, okay, then you can make the method as synchronized. Correct? Good. So let me talk about statement. Synchronized blocks or block is better than synchronized method to improve the performance. Okay. Then synchronized method to improve the performance. Because it makes the waiting time is less for a thread. That's how it will improve the performance. Okay. But of course, then why synchronized methods are given? If, for example, all the statements are critical statements in a method, then instead of writing the block, you can directly just make the method as synchronized. That's the option given for us. Okay. What if, for example, so how many synchronized blocks we can write inside a method? Multiple. Okay. In a method, we can define multiple synchronized blocks also. In a method, we can define multiple synchronized blocks also. In a method, we can define multiple synchronized blocks also. Okay. Let's say, for example, I'm writing public void method 1. Okay. And it has one synchronized block. Synchronized. To the synchronized block, we should pass object as a parameter. Which object? The object whose lock a thread is going to acquire, or a thread is going to acquire the lock on it. This means the current object. Synchronized of this. And what can I write here? I can write something like statement 1, statement 2. The two statements. For example, statement 3 and 4 are not critical. I can write outside. Then again, I'm starting synchronized of this. Then I'm writing statement 5, statement 6. Okay. So you can write multiple blocks also like this now. What happens now when thread 1 comes out of the first block, then thread 2 will enter into the first block. Correct? So after executing 3 and 4, if a thread 1 goes to second synchronized block, thread 2 will wait outside of this block. Okay. Which means what? Thread 2 is not waiting until the entire method is completed by the thread 1. I mean, until the method is completely executed by thread 1. Okay. When thread 1 is coming out of the block 1, thread 2 will enter into the block, and thread 1 is continuing with the statement 3 and 4. It will enter into second block. Meanwhile, thread 2 will complete this block and will execute 3 and 4 and will wait. Which means the second thread is not waiting until the first thread executes the entire method. It is also coming behind thread 1. Okay, along with thread 1, thread 2 also coming without waiting for much time. That's how this will help us. Okay, this concept name is called synchronized blocks. Okay, there are two things are there. One is a synchronized method and second one is synchronized block. Next. This is the one thing I want to complete as part of the synchronization topic. Now, we will understand next concept as what is deadlock. We'll understand about what is deadlock. Okay, then we'll see how we can write the code for deadlock. And we'll see the solution for deadlock. Okay. Just I want to, instead of typing the same statements, I just want to repeat the same statements for you. See. Let's understand about what is deadlock. Let's understand about, we want to know about what is deadlock. Okay. Let's say suppose we have two threads and two resources. Two resources, I mean two objects. Thread 1 holds lock on resource 1 and waiting for lock on resource 2. And thread 2 holds lock on resource 2 and waiting for lock on resource 1. Okay. Which means I will tell you how it is going to work out. I have two threads now. I have two threads and I have two resources. Two resources, I mean two objects. Thread 1 holds lock on resource 1 and waiting for lock on resource 2. Thread 2 holds lock on resource 2, waiting for lock on resource 1. Now, in this case, what happens? Thread 1 is blocked for resource 2 and thread 2 is blocked for resource 1. So the two threads will never complete. This is called deadlock. Let me show you how it is going to be. I mean, just for understanding it, I'll tell you how it is going to be. So how to prevent the deadlock? A deadlock can be prevented by making the two threads to acquire the locks on the resources in the same order. Let's see how it is going to be. Let me just explain how it is going to be. Let's say there are two threads now. For example, I have two threads. I will write thread 1 and thread 2. I will write thread 1 and I will write thread 2. I'll take two objects and let's say thread 1 holds lock on resource 1 and waiting for the lock on resource 2. So thread 2 is holding the lock on resource 2 and waiting for lock on resource 1. So let's see how you can understand this. I will do one thing. I will write the logic in the run method of thread. So two threads I want to create. Okay, by extending thread class, I want to create two threads. For example, I'm writing one class my thread 1. Extends thread. Just this is only for understanding. Next, we'll see the complete code. We'll have the deadlock program next. Okay. Then we are going to override run method. Public void run. Here what I'm writing is, for example, synchronized of, let's say obj1. Obj1 means otherwise resource1, res1. Just for understanding only. Later we'll see the code. And it is having some statements. And from this synchronized block, now I'm writing another synchronized block inside it. Synchronized of res2. Under this inner synchronized block, there are some statements. So we can write what? Synchronized block inside synchronized block. Don't worry, we can write. Okay. Let's say the class is closed. This is first thread. Coming to second thread. Okay, guys, what I'm writing class, there is a thread called what? My thread 2. It extends what? Thread. Then what we will write? At the rate override. Public void run method. Inside the run method logic is synchronized of res2. Some statements are there in this. Then synchronized of what? res1. Correct? That's how it works. Am I clear with you now? If you look at this now, for example, 2 threads are started parallelly. Then what happens now? Thread 1 is acquiring the lock on resource 1. Now thread 2 is acquiring the lock on resource 2. Both the threads are started parallelly. So thread 1 has acquired a lock on resource 1. Thread 2 has acquired a lock on resource 2. But again, thread 1 is trying to acquire the lock on resource 2. Correct? Thread 2 is trying to acquire the lock on what? Resource 1. Actually, thread 1 has already acquired a lock on resource 1. I mean, resource 1 is object 1. Correct? Thread 1 has already acquired the lock on resource 1. And it also wants to acquire the lock on resource 2. But already thread 2 has acquired the lock on resource 2. Now it is waiting for, or it is trying to acquire the lock on resource 1. It is trying to acquire the lock on what? Resource 1. Now what is the problem here? Thread 1 wants to acquire lock on resource 2. Who should release that lock? Thread 2. Because thread 2 has already acquired a lock on this. If a thread 2 wants to acquire the, release the lock, it needs lock on resource 1. But already thread 1 has acquired the lock on resource 1. It cannot release because it needs lock on resource 2. It wants to acquire lock on resource 2. After completing the task only, it can come out of the synchronized block. Okay, is this clear, guys? how deadlock occurs?
Yes, sir.
How deadlock occurs? This is how deadlock will occur. Okay, what is the problem here? The problem is thread 1 has lock on resource 1, waiting for lock on resource 2. Thread 2 has lock on resource 2 and waiting for the lock on resource 1. Thread 1 cannot release this lock. Similarly, thread 2 cannot release this lock because to release this lock, thread 1 needs lock on resource 2. Okay. To release this lock, thread 2 needs lock on resource 1. So they will never complete. This is called deadlock. So what is the solution for deadlock? To prevent deadlock is get the locks in the same order. If you get the locks on the same order, what happens now? For example, if thread 1 got the lock on resource 1, then thread 2 cannot get the lock on resource 1 here again immediately. So acquire the locks on the threads in the same order. Resource 1 after resource 2, resource 1 after resource 2. If first thread 1 has got a lock on the resource 1, then thread 2 cannot acquire the lock on resource 1 immediately. So first thread 1 will complete, then thread 2 will complete. If first thread 2 got the lock on resource 1, thread 2 will complete first, after the thread 1 will complete. So we never get any deadlock. This is how the statements are written here. Okay. Suppose we have two threads and two resources. Two resources, I mean two objects. So thread 1 holds lock on resource 1 and waiting for lock on resource 2. And thread 2 holds lock on resource 2 and waiting for lock on resource 1. Who are resource 1, resource 2? They are objects. You can use any objects. They are objects. So in this case, thread 1 is blocked for resource 2 and thread 2 is blocked for resource 1. Correct? Correct? Okay, that's how, guys, that's how this deadlock can be prevented by making the two threads to acquire the locks on the resources in the same order. That's how it is going to work. Okay, let's see how we can able to write the code for this. Correct? We'll start writing we're trying to, we want to, okay, we want to write some SOP statements also to check whether how a deadlock is going to occur. And we'll see how a deadlock can be prevented. First, we'll see deadlock, then we'll see how to prevent the deadlock. In the same example, okay, one example we will start. Clear? So let me start. We have our workspace. Let me check if I have already programmed, then I will show the same program to you. If not, then I think I don't have. So I will start writing the new code. Okay. Okay. Right. It is not a Deadlock program. We'll write the deadlock program now. I just want to show you how the deadlock occurs. We'll write the program, then I'll copy the program for you into the document. Okay. It's a deadlock program. Now, in the deadlock program, what I just want to explain. I want to start creating a new class. Package name can be something com.ashokit.demo. That is a package name, and a class name is, I'll do one thing. I can even write, guys, I can write through Java 8 also. I mean, you know about runnable. Runnable is a what? Runnable is a functional interface. So we can implement a functional interface using Lambda. Okay. Runnable is also a way of creating a thread. As you all know that a function interface can be implemented through Lambda expression. So let's do one thing. Because you know about Java 8 Lambda expression, runnable is a function interface. This time we'll create the two threads using runnable, means by implementing runnable through Lambda. So I want to give program in that way, so that once again you will recollect the Lambda expression what we discussed in Java 8 feature. Let me do one thing. I'll start writing class name as main class with main method. Here, first I want to create two objects, two resources I need, just two objects, object class objects I'm creating. I want to make them as static. If I want to use them there, then I should make it as final. Okay, no issues. Final object res1 equal to new object. Nothing but I'm creating an object class object. Static final object res2 is equal to new object. Nothing but we are creating the second class object. Okay. Static final object res1, object res2. Two objects are there. Now next, I'll show you. Runnable task1 is equal to arrow token and start the body. Do you know how can we implement runnable interface now? Actually, we can create a class, but runnable is a function interface. So a function interface can be implemented through Lambda expression also. And we can store, if you want to store, even you can store the Lambda expression into a reference variable also. The target of a Lambda expression is a interface reference. This is a Lambda expression, right? Run method has no parameters, empty. Arrow token, start the body. Now inside the body, what I will start writing? Synchronized of res1. I'll add SOP statement. As you know that synchronized is a keyword. Okay, synchronize is the keyword of RES1. Resource 1, I am writing SOP. Let's say thread dot current thread dot get name, means get the current thread name, has acquired lock on resource 1. RES1. RES means resource 1. Resource 1 means object 1. Just acquired lock on resource 1. Because it entered into synchronized block now. Now let's do one thing. Keep some sleep time, thread dot sleep, because I want to meanwhile allow the second thread also to enter into running state. Let's say sleep of 2000. Define a cache block to catch interrupted exception, because sleep method throws sleep method, yield method, join method, they throw interrupted exception. If you want to display the exception, if any exception occurs, you can display with system.out.println. Now this is all in synchronous block on RES1. Now I will write SOP. Same. Thread dot current thread dot get name is waiting to acquire lock on resource 2. Okay. How to acquire the lock on resource 2? Synchronized block. Synchronized of RES2. Okay. And I wanted message saying that acquired lock on resource 2. If really acquires. Acquired lock on resource 2. Okay. So this is a thread. Now this thread is first acquiring lock on resource 1 and entered into the block and executing some statements. Then trying to acquire the lock on resource 2. Let's create one more thread. It has acquired already lock on resource 2 and waiting for lock on resource 1. I mean, almost the same code, but a bit change that I'm going to do it now. First of all, I want to close this with a semicolon, which means what? This lambda expression body is completed. The lambda expression body started here at line number 10, and line number 26 is the ending curly brace. At line number 11, there is a curly brace started. Its end is line number 25. Okay. And there is a curly brace started for try block. That try has a corresponding catch. This is catch block, started, closed. This is synchronized block, started, closed. So try to find out opening curly brace and closing curly brace. And that's going to be a very important one. This is the definition of first thread using lambda. Means we are creating thread through implementing lambda. Implementing runnable. But runnable is a function interface. So we can provide implementation through lambda expression. So that's what I'm doing here. So basically what I did here, I just created the implementation through lambda expression. Same thing I need Just the same thing, but task 2. Where we can store the lambda expression, we can store the lambda expression in interface reference variable. We can store, if you want to store, we can store. Where can we store? In the interface reference variable, we can store. Interface name is runnable. Reference variable name is task2. But it is reverse now. It is res2. So first thread 2 acquires lock on resource 2 and waiting for resource lock on resource 1. Okay. Correct. So there are 2 threads here, thread 1 and thread 2, task 1 and task 2. So that's how it works. Okay, just reverse order. Here first thread is first getting log on resource 1. Second thread is getting lock on resource 2. After getting the lock on resource 1, it also wants lock on resource 2. After getting resource 2 lock, it also wants to get the lock on resource 1. Basically what? Resource 1 lock is with the thread 1, resource 2 lock is with the thread 2. Resource 1 is locked by thread 1, resource 2 is locked by thread 2. If a thread 2 want to release lock on resource 2, it needs lock on resource 1. The thread
it requires lock on resource 2. That's where deadlock occurs. Okay. Currently, I have created what? Currently, I have created what? 2 threads I have created. But this time it is new for you. First time you are writing, you are seeing the code like this. Because previously, you know what? Extends thread class implements runnable. But what I'm telling you now, because you know lambda expression, if you have a function interface, you can also implement the function interface using lambda expression. So this is a lambda expression I'm using to implement the runnable interface. We can store the lambda expression in the interface reference variable. The reference variable name is task2. Here the reference variable name is what? Task1. You can do like this. Now finally, these are 2 runnable objects. But you know, directly we cannot start the threads. We cannot start runnable object directly because runnable has only run method, but you don't have any start method or some other methods. You don't have any start method. Start method is there in thread class, but not there in runnable object. That's why we need to wrap the runnable object to thread object. Let's create 2 threads now. Thread T1 is equal to new thread of task1. Give a name. Let's say, for example, thread 1. Actually, when you are creating thread class object, while constructing thread object, we can pass runnable object as a parameter and thread name as a parameter. I mean, we have a constructor with the 2 parameters. What is thread 1? It's a name. For understanding our code, we need the name. I gave the name as thread 1. This is a way how you can construct what? Thread object. You can create a thread object by passing what? Runnable object as a parameter. We are constructing thread object here by passing runnable object as a parameter and a name as a parameter. We can pass runnable object comma name. Similarly, thread 2, T2 equals to new thread of task 2 comma thread 2. This is how the 2 threads are created. Why I'm again creating T1, T2, the thread class objects? Because task 1 and task 2 are runnable objects. Directly I cannot write. See, directly I cannot write task 1 dot start. I cannot write. I'll get error. Or task 2 dot start, because Runnable interface has only one abstract method called run method. In a runnable object, we don't have start. If your object is runnable type, then you have only run method, but you don't have start method. Here my object is task1, it is runnable type. It is runnable type. If it is runnable type, you have only run method in that runnable, but you don't have start method. That's why you are getting error at line number 47 and 48. Okay, am I clear now? Why I'm creating the thread objects here? Am I clear with you? Why line number 47 and 48? Can you tell me?
You can make them run.
What are we doing? What are we doing at line 47? What are we doing at line number 47, line number 48?
We have created thread one.
We
thread
are creating
two,
objects for the threads. In functional interface, there will be only one abstract method, so we can't directly create the.
We can directly run the
What are we
run
doing at line
method
number 47? What are we doing at line number 48, 47 and 48?
We are creating
create
objects.
thread
Can you
object
tell me what we are doing? Do anybody know what I am doing at line number 47?
to call the run method by calling the start method. Calling method through Sir, we are unable to hear your voice. Sir, you are not audible. Hello.
Sir is not able to hear us, I think so.
Okay. Yeah.
Sir, your voice is not audible up to now.
Now my question is that okay? Is the program execution is completed?
But
It has acquired deadlock. Hello, sir.
The question is now, is that program execution is completed? Am I audible to you now? Can you able to hear me?
No, sir. No, sir.
So now your voice is not audible, sir. Now it is audible. I think sir is not able to hear us.
Yeah, I think I'm audible to you. You are audible to me now.
Yes, I can hear you.
Okay, sir.
Yeah. Got it. Thing is now, what happens to the question is now what happens to this program now? Is the program execution completed? Do you think that this program is over?
No,
Is
sir, it
execution
will.
is done?
No, sir. Repeat again this question. This program.
No, I'm asking about is the program execution completed or still the program is executing?
Executing, sir. It is keeps on
It's
waiting.
executing. It is keep on waiting. If it is executed, you will get a message here that if execution is completed, you will get a message here terminated. At the same time, you can't see this red button highlighted. This red button becomes gray if execution is completed. You can't see the red button there. You can see a gray button, which means what? My program is still executing. Thread 1 is waiting, thread 2 is waiting. Thread 1 will never complete, thread 2 also will never complete. Correct? Now I'm going to manually terminate by clicking on the stop button. Now it is gray. Now you got the message terminated here because I terminated manually. I have terminated manually. It is not done by program because it's deadlock program. Now let's go back. Let's go back. Let's see one thing. Just to know how the deadlock occurs and how the program we can add on deadlock. Let's go back. Let's see here. How can I prevent deadlock is both the threads should acquire the locks in the same order. First it is acquiring, thread 1 is acquiring lock on resource 1. Okay. Thread 2 is acquiring lock on resource 2. They are acquiring locks in different order. If a thread 1 acquired lock on resource 1 and thread 2 holds lock on resource 2, thread 1 also wants resource on resource 2, lock on resource 2. But already thread 2 has it. And it will not release because it wants lock on resource 1. So we are getting deadlock. The only way is the two threads should acquire the locks on the same order. Okay, for example, if resource 1, then resource 2. It first holds lock on resource 1 and next trying to acquire resource 2 lock. It is first acquiring resource 1 lock, then trying to acquire lock on resource 2. If the two threads are acquiring in the same order, then only deadlock can be prevented. Now there will be no deadlock because I have changed it to resource 1, then resource 2. I have to also modify resource 1, resource 2. My code. Okay. Even I can add one more message saying that what this thread completed, that thread completed, like that. For example, system.thread name. After the second, okay, once after the second statement or once after the synchronized block is completed or synchronized block is over, then I want to say that current thread get name is completed. Here also what I will write, thread completed. is completed. So this is how we can prevent deadlocks. Now, if I run the program, there will be no deadlock because the two threads are acquiring locks in the same order on the resources. Resource one first acquires lock on resource one, then waiting to get the lock on resource two. Here also same thing in the same order. If they are acquiring locks in the same order, then there will be no deadlock occurs for the two threads. Because if a thread one already holds lock on resource one, then thread two cannot get the lock on resource one again. So first thread one will complete release lock on resource one, then thread two will get the lock on it, which is nothing but what? The two threads will complete one after the other without any deadlock. If I run, now we can see output like this. You got a message called terminated, not like waiting. And you have the gray button here, which is nothing but the execution of this code is that execution is completed. That stop button is grayed out. You see thread one has acquired lock on resource one. Then thread one is waiting to acquire lock on resource two. Thread one has acquired lock on resource two. Thread one is completed. After thread one completed, then thread two started. There will be no deadlock. This is the way how we can prevent deadlock. Okay, but if I write in reverse order, this is thread one is acquiring resource one, then trying to acquire lock on resource two. Thread two already acquired lock on resource two and trying to acquire lock on resource one. This is called deadlock. Now I have to change because I have to show deadlock program into the document. How to prevent deadlock? By doing a small change. Put the same order. But I am copying deadlock program to you, not the solution program. This is called deadlock. This code will never complete. The program is not terminated, still it is running. Thread one is waiting to acquire lock on resource two. Thread two is waiting to acquire lock on resource one. Okay. Thread one waiting to acquire lock on resource two, but where is already thread two has acquired it. Thread two is waiting to acquire lock on resource one, but already thread one has acquired it. Which means thread one will never complete, thread two will never complete. This is called deadlock. Okay. Terminate manually with the stop button. This program I will copy for you. Please go through this program. I created two resources, nothing but two objects. Just I'm creating the two objects of object class because I want to show you deadlock. And because a static method allows only static variables. That's why I made static. And if I want to use these objects in the blocks, for example, here I'm using res1, here I'm using res2. If I want to use any variable inside a block, okay, inside a block of a method, inside a block of a method, then we should declare it as a final. So I took the two variables, res1, res2, both are two objects of object class. We know superclass is object for all classes in Java. That's how deadlock works. Okay. So this is a sample code for deadlock. That's a deadlock program. This is how deadlock program works. This is how deadlock works. Okay, right. So you got almost all the things. And I'm just giving an hint or intimation that today you also learn about a concept called as what is inter-thread communication. Tomorrow I'll give a homework to you. Learn about wait, notify all. These methods are used for inter-thread communication. These methods are used for inter-thread communication. Wait, notify, and notify all. In multi-threading, we have a concept called as inter-thread communication with methods wait, notify all. They are the methods given in object class, not in thread class. Okay. First you go through them. Today. Then tell me what you understood about it tomorrow. Tomorrow also with the class at the same time. Tomorrow also with the class at 7:30 in the morning. Okay, I'll start session tomorrow at 7:30 only. Today started at 7:40, but tomorrow will start at 7:30 only. At 7:30 morning, tomorrow also we have the class. And we will continue. We have to discuss about a concept called as some concepts are there like cloning. Okay. I'll talk about what is cloning, what is serialization. Okay, tomorrow I'm going to explain this. And what is enum? There are some couple of things are there. And what is package? Okay. So around, I'll take 2 hours of session to just explain about, okay, just to explain about what is cloning, what is serialization, packages. Okay, enum class. Enum is not a class, enum type. Just to get an idea of what is enum in Java. Enumeration type. So there are like 3-4 couple of concepts are there. I'll explain and I'll finish this core Java topic tomorrow. By taking from 7:30 to around 9:30. It may be something like that.
Is there.
Okay.
Hello.
That's what we are going to discuss for today, and we will continue. Meanwhile, I'll share this multi-threading document now, and you just go through this. Okay. So I will share in the chat box itself now. Better you download now itself.
Videos are not uploaded, sir.
Sorry.
Java 8 backup videos are not uploaded, sir.
That we need to connect with admin. I'll also connect with admin. You please ask. You also please connect once with admin. Okay. I'm going to share this. Yeah. Please.
So can you